Hi, welcome back to my workshop. This is going to be part 3 of learning some Next Basic, and I'm going to cover Sprite over. Before we get to that, I just want to look at reading a joystick, and this is based on routines by Dallas Sloan. So we'll quickly look at moving a sprite around the screen with the joystick, and then we'll get into some Sprite over. We're just going back to some simple sprites, so I can show the hitboxes. So we have 16 by 16, and then when it's hit, it goes red, and like a character, which is 8 wide, and you would put it in the middle, and a hitbox, and then a smaller one, 8 by 8, and again in the middle, and then even a smaller one. So we'll just get these moving around the screen with the joystick, and then we'll use the sprite to continue to get something on the screen, and then we'll just show how to do the collision. This time I'm going to work in Visual Code with Remy's extension. So this is reading a joystick, and we're using one of the Spectrum registers, register 31. So we're basically reading a poke, a register that's at 31, and it returns a value. And the way that we're reading the joystick is with a binary value, because we want to read individual bits that's returned. If you don't do it this way, you'll run into some problems. Let's say if we wanted to see what's going on when we press right, it would be if nothing is pressed 0, if 1 is pressed, then we're going right. But when we press right and fire, it would no longer equal 1. So we would have to check for right and fire. But then let's say if we did up and right and fire, we would have to have combinations of all of those. So up, right and fire, up and fire, fire, up and right. If we do it with the flags, then we're just checking for individual bits. So what we've got here is we've got if the joystick value and the binary 1 equals 1, then that means that the bit 1 is actually set because we've compared it to bit 1, and we're ignoring all the others. And then when we've got left, it's the second bit, so it would be the same as being 2, but it's ignoring all the others. So that means we're individually checking the bits, so we only need to check them once. So we could have 8 directions, up and right and fire, all within just reading it once and doing the bitwise comparison. The joystick that I'm using is Competition Pro Extra, so it plugs in via the USB port on my PC. This will just be the same as using any DB9 style joystick on your Next. It's the exact same port that it's reading. So on VS Code, we do with Remy's extensions, Control S to save, Control Shift and R, and as long as you've programmed in where to find cspect, it will automatically launch it. Remy has instructions on how to do that, so I'll post a link to his website. So we just move the joystick right, left, up, down, and fire. But we can do up and fire, right and fire, and any combination that we're doing. So it's that simple. So all we would do, we would just change these lines at the end where it says print, and we would increment an X and a Y value. So I've not really done this very well. So I'm just going to open up HDFM GUI. We want to go into devel, which is where the VS Code puts everything, and our file is Sprite over. So let's layer 2, comma 1, load over.spr, bank 15, sprite, bank 15, sprite, print 1. So we're loading our sprite file over.spr to bank 15, setting the sprite bank to 15, and then turning and then enabling the sprites. Let's do 40, let x equal 100, let y equal 100. Sprite 1, comma x, comma y, comma frame 0, and then turn it on, sprite move int. So we've done that, and then we want to remove our print commands. So I'm not going to print anything if we're not moving. We want right to be x equals x plus 1. Left is x equals x minus 1. Down equals y equals y minus 1. Sorry, plus 1. Y equals y minus 1. So changed our print commands, removed, put in the increment, the x, decrement, the x, and the y. Let's save that and run. So there we have our basic sprite. Let's just put in run at 3 to get full speed. So there is our sprite moving around the screen with the joystick. So before our loop, sprite 2, 150, 150, and we'll do the red block, and we'll turn it on. So now we want to detect when our white box touches our red box. So I'm going to just set up another variable. Let's do s equals 0. And we'll change our player sprite to s. So if we do if %, because it's returning a value, sprite over bracket. The first one is our sprite that we want to check, which is 1. And then it's comma, our second sprite that we want to check for a collision against, which is 2. So that's the most basic element. So it will return a value of true if it hits, because there's only one. Then s equals 1. Save that and run. So we have our white box and he turns red when he touches the red sprite. But let's say we want to change that so that when it's not touching the red sprite, it goes back to the white box. So if we change this line so that it equals 2, so when it's touching 2, then we want to say set our sprite to 1. And then if we copy that, Control C, and we say if it equals 0, then it's not touching anything. Set our white box back. So now you can see as I move around, it changes color. Let's say you wanted to do a smaller object. So I've just been doing the janky miner, and I have a smaller object that I want to detect. So if we go back to our sprite field, let's use sprite number 5. So let's change the second one so that it looks like 5. So you note that because the sprite is smaller, we're detecting it when we're not actually over it, because we're detecting the whole 16 by 16 area around the sprite. So there's an additional part to the command. So if we put a comma, and then we can specify how many pixels coming in from the outside. So if we put 4, 4, so now we should be able to get closer to our red square. And we can. So we can get right up next to it. So even though it's a 16 by 16 sprite, we've set a buffer around, it's called an overlap. So that will allow us to get closer. And then let's go back to this, and let's use sprite number 3. So that should be 4 on the X, 0 on the Y. So we can overlap on the sides because the character is narrower, but not the top and bottom. So we should be able to creep up on the side, but not the top or the bottom. So that is that's the basic of sprite over, and how you can specify a smaller region within your 16 by 16 destination sprite. The next part is we might have more than one sprite that's on the screen, so let's add a few more. And we'll say 3 and 4, and we'll do just 50 and 50, and we'll leave everything else as it is. So we should have 3 enemy sprites on the screen now. So these ones don't do anything, but when we touch this one, it turns red. So now let's say they're all enemies, they're all moving around on the screen, and we just want to know when any of them touches. So on our sprite over command, we put in there 2, 4. So that would do a range of sprites. So any time that sprite number 1 touches 2, 3, or 4, then it will trigger. And we want to take off the 2 because we don't want to know when it just hitches 2. We want to know when it's all of them. So it'll either be a 0 when we're not touching, or it will be not 0 when it's touching one of the others. I forgot the second line, didn't I? 4, 4, 0. So our second line, where we're turning back, also needs to be set up with the 1 to 4. So there we go. So we can now touch any of the enemy sprites with that same command, and it will turn it off. Now we want to do something when we hit that sprite. So we want to really allocate a value to the sprite. So I'm going to add :E for enemy equals 0, and we will change E equals. So now E is going to contain the value of the sprite. And we can change that second line off. So if E equals 0, then S equals 0. If E is greater than 0, then let's turn that sprite off. So sprite E, 0, 0, 0, 0. So that should turn whatever sprite off that we touch. And then also, at the end of that, s equals 1. So we get a brief flash, and our sprites have disappeared because we've touched them. That could be like we've picked up an enemy key, we've picked up a key, or something along those lines. So that's a simple way to detect a multiple number of sprites that are moving around the screen or stationary, doesn't matter. And then we can assign a value and turn them off or trigger a new animation, change a movement, anything that we've done with the sprite continue, we could actually do with that. Let's just to carry on this, let's do sprite continue to 50 to 1, 50 to 250, step 1, run 150, stop, and 150, stop, 3, and I think it's 64 because it's not moving anywhere, comma 0. So that should move around the screen now. So it's moving on the screen, and then as soon as I've touched it, it's turned it off. So I hope that explains that. The way that I'm thinking about this is you would have like a group of sprites, and like sprites number 10 to 20 would be enemies. So you would group them all together, and then you would have one sprite over command that deals with just that enemy, and then when whatever it receives back, you process it. Then you would have sprites 20 to 30, which would be things that you pick up. Sprites 40 to 50 could be things that just instantly kill you. So depending on how you group your sprites around, and then using the value and the sprite over, you can process them in different ways to get parts of the game going. So let's just quickly run the game that I've been working on, Janky Miner. And we can see some of the things that I've been talking about. So on this screen, the green trees and the ice at the top are sprites, and they've got hitboxes around them. Same with the keys, but the conveyor belt is also a sprite, but we're not gonna worry about that. So as we're jumping, I've hit the sprite, so I've instantly died. Same goes for the enemy, he's also a sprite. Let's quickly get up to a key. So a key is using the same technique that we saw when I turned the block off. So I've just got all the keys are in one group, and as soon as we touch one of those keys, it knows which one and turns the sprite off and increments a number. Simple as that. And then anything that's going to hit me is just grouped together, and same that we saw, just tick in action as soon as it hits us. This game has also got a few other things. So when we're walking over these floors, they're disappearing, but they're not actually sprites. I'm doing a tile map function. So we'll cover that in another video. So that's basically sprite over. And it's just a matter of grouping your sprites together, and then if you want to specify a smaller part of the sprite, then you just reduce the number, you put an overlap around the edge. If it's 0, it's the full range of 16 by 16. if you was to do 4 on the X and 4 on the Y, then you could detect if you've only hit an 8x8 square in the middle of the screen. So thank you for watching this. I hope that makes sense. Like before, the program will be in the description, and if you have questions, put them in the comments down below. Thanks for watching, and I'll see you on the next one.